Okay, in today's lesson, we're going to be looking at theorem number 7, which says a tangent to a circle is perpendicular to the radius at the point of contact. So this is to say if ABC is a tangent here to the circle at B, then the radius OB will be perpendicular to this tangent ABC. That is to say, if we split this to B1 and B. Okay, now let's look at A. In this exercise, we are required to find the missing values of the angles. So in this one, we are required to find only x, but then applying our theorem, we can see that OB is a radius and ABT is a tangent. Now, what do we know? The radius is perpendicular to the tangent, so we'll have our 90-degree forming here. So in order to find the value of x, we can use the sum of interior angles. But then let's first start by saying OBT, angle OBT, should be equals to 90 degrees, and the reason is tan perpendicular to radius. Now, to find our x, we'll say x is equals to 180 degrees minus 90 degrees minus 35 degrees, and then the reason is sum of interior angles of triangle. Then x is equals to 55 degrees. Now let's move to B. Okay, in B, we can see a similar situation, OB radius and ABT tangent. So radius is perpendicular to the tangent. We have our 90 degrees there. So now we can say angle OBA is equals to 90 degrees. Remember, you must always offer a reason. Then tan perpendicular to radius. So we'll say 2A plus 3A plus 90 degrees. So we are using this triangle here to find the value of A is equals to 180 degrees. What's the reason for that? Sum of interior angles of triangle. Now, what is 2A plus 3A? That's 5A. Then if we take this 90, transpose it that other side, we have 180 minus 90. That's 90 degrees. Then we can divide both sides by 5. Then A is equals to 18 degrees. Okay, so now we have C. For C, we can see that OC here is a radius and OB is a radius. Now, by virtue of doing this, we can see that we have formed an isosceles triangle OBC. Therefore, we know that base angles of an isosceles triangle are equal. So that means we also have 50 degrees here. So we can say angle OBC is equals to 50 degrees, and then the reason for that is base angles of isosceles, or we can indicate that OB is equals to OC. Right, now if we have that 50 degrees here, let's look at the theorem. We are required to find x. We can see x is here, OB here is a radius, and ABT is a tangent. Now we know tangent is perpendicular to radius. We have 90 degrees here, so let's indicate angle OBT is equals to 90 degrees, and the reason is tan perpendicular to radius. But then the OBT is now defined as x plus 50 degrees, which is equals to 90 degrees. Now if you take this 50, transpose it to the right hand side, we have 90 minus 50. That's going to give us 40 degrees. Right, so we have 40 here. Now looking for y, can see that if we want y, we can just start by calculating this angle here, right? So we have 50 degrees and 50 degrees, and then what is angle OBC? Our angle, not OBC, BOC. So what is angle BOC meant to say? So angle BOC will be equals to 180 degrees minus 50 degrees minus 50 degrees. So why are we doing this? Sum of interior angles of a triangle. So you see this triangle OBC, so we are using that one. So sum of interior angles of triangle. Then BOC now should be equals to 80 degrees. So if we have 80 degrees here, we want to use now the right angle triangle. So OBT, triangle OBT, to find the value of y, right? So now to calculate y, we'll say y is equals to 180 degrees minus 90 degrees from here, and then minus the 80 degree we just calculated. And the reason for this, once again, is sum of interior angles of triangle, right? So our y is now equals to 10 degrees. Okay, now moving to D, can see that OB here is the radius and it is perpendicular to the tangent ABT. So we expect to have 90 degrees here. Then can say OBT is equals to 90 degrees, is equals to 90 degrees, and the reason is tan perpendicular to radius. And then now the OBT is defined as x plus 40 degrees is equals to 90 degrees. Take this 40, we transpose it this side, then x is equals to 50 degrees. So we have 50 degrees here. Then how are we going to find y? We can see that COB here is a diameter running from the circumference to circumference passing through the center. This is a diameter. Now from our theorem number 3, we know that a diameter will subtend an angle of 90 degrees at the circumference. So y is equals to 90 degrees. And what's the reason for this? Angle on a semicircle. Okay. Then to calculate for m, we have 90 degrees here and our x is 50 degrees. We can use the sum of interior angles of a triangle. So CDB is a triangle. So we'll say m is equals to 180 degrees minus 90 degrees minus 50 degrees. And then we say sum of interior angles of triangle. Note that I'm not using tan chord theorem here because we haven't touched on tan chord theorem. So if you already know it, you could have used the tan chord theorem, but then remember the purpose of these activities is that we focus on one theorem at a time. Then m is equals to 40 degrees. Okay, let's look at E. So when looking at E, we can see that OB once again here is the radius and ABT is a tangent. Now we know the tangent is perpendicular to the radius, so angle OBT should be equals to 90 degrees. So this angle here should be 90 degrees. So we have OBT is equals to 90 degrees, and the reason for that is tan perpendicular to radius. Now the whole angle OBT is the same as saying A plus 38 degrees. Then we have 90 degrees here. To calculate our A, we can just say 90 degrees minus 38 degrees, and our A will be 52 degrees. Okay, so now that we have 52 degrees here, how are we going to find B? Checking that, we can see that BOD is a diameter passing from circumference. So it's from circumference to circumference passing through the center. That's a diameter. And we know from our theorem number 3, a diameter will subtend an angle of 90 degrees at the circumference. So our angle BED, so BED, this angle here, will be equals to 90 degrees. And the reason is angle on a semicircle. Now that we have BED is 90 degrees, we can use it to calculate B. So we see that this whole triangle here, this is a triangle BED, and then we can use the sum of interior angles to calculate B. So B is equals to 180 degrees minus 90 degrees minus 52 degrees. And then the reason for that is sum of interior angles of triangle. Then B is equals to 38 degrees. Okay, now if we have 38 degrees here, how are we going to find C? Now you can see that if we hold chord BE subtends an angle here B, which is now 38 degrees, and then also holding chord BE, we can see that it subtends another angle here, which is angle C. Now we know that angles subtended by the same chord will be equal. These are angles on the same segment. So C will also be equals to 38 degrees. And then the reason is angles on the same segment. Okay, now looking at F, we can see that now they decided to put our tangent by the side here, but then it doesn't change anything, right? Remember, we know the theorem states that the tangent is perpendicular to the radius. So wherever they meet, they will form an angle of 90 degrees. So as we can see here, we can see that OB here is the radius, and then also OC here is the radius. So by virtue of doing this, we can see that we have formed an isosceles triangle. That means if this is x here, also C1 should be x. But then in order to calculate our x, let's use the theorem. The theorem says that the radius will be perpendicular to the tangent, meaning this whole angle here, OBT, should be equals to 90 degrees. So we can say, let's start off by saying angle OBT is equals to 90 degrees. And then the reason is tan perpendicular to radius. Then the whole angle OBT is defined as x plus 60 degrees. So that means x plus 60 degrees is 90. And then to calculate for x, we'll just say 90 degrees minus 60 degrees. And then our x is 30 degrees. Okay, so now if we have 30 degrees here, and then we said that C1 is base angles of an isosceles, meaning we also have to have 30 degrees here. So let's say C1 should also be 30 degrees. And then the reason is base angles of isosceles. Can also indicate that OB is equals to OC. Right, so now if we have 30 degrees and 30 degrees, that means we can find our O1 here. So O1 will be 180 minus 30 minus 30. Right, so O1 will be equals to 120 degrees. So 120 degrees. And what's the reason for this? This is sum of interior angles. Sum of interior angles of triangle. Right. But then why are we calculating the size of O1? We are seeing a particular theorem here, which is theorem number 2, which says an angle at the center is 2 times an angle at the circumference. Right. So we are calculating O1, the angle at the center, and then we want to form a relationship with it from the angle at the circumference. So we know the angle at the circumference should be half the angle at the center. So now we have found y. Y is equals to 60 degrees. And as our reason, we say angle at center. Angle at center is equals to 2 times angle at circumference. So angle at center is twice the angle at the circumference. Nice. Now let's go for G. In G, we are required to find the missing values x, m, and y. So how are we going to calculate that? If we check here, we can see that OB here is the radius and OD is the radius. Right. Now we see that this radius is perpendicular to the tangent ABT. So this whole angle here is 90 degrees. But then the problem here is that we don't have this angle here. So what can we do? By virtue of saying that OB is equals to OD, we have formed an isosceles triangle, meaning this angle here and this angle here, they should be equal. These are base angles of an isosceles triangle. So we can say ODC, ODB, meant to say ODB should be equals to OBD, OBD. And this two should be equals to 20 degrees. Why 20 degrees? Because if we can check sum of interior angles here, if we have 140 degrees, they should sum up all this, the interior angles of a triangle should sum up to 180. So that means we are only left with 40. If these are equal, the 40 should be split equally amongst this angles. So that means we have 20 and 20 here. So ODB is equal to OBD, and they are equals to 20 degrees. And that's because base angles of isosceles. Base angles of isosceles. So your OB is equals to OD. Okay, so now that we have the 20 degrees here, we can now use it to calculate x. So we see that this is a radius and it is perpendicular to the tangent. So perpendicular means they form 90 degrees. So that can be defined OBT. We can say OBT is equals to 90 degrees. And then we say tan perpendicular to radius. But then the OBT can be defined as x plus 20 degrees. So x plus 20 degrees is equals to 90. Then calculating for x, we'll say 90 degrees minus 20 degrees. So x is equals to 70 degrees. Okay. So now how are we going to find y? For y, we can see that here we have an angle at the center, and then y is an angle at the circumference, subtended by the same chord BD. So BD here is subtending an angle O at the center, and also holding chord BD, we can see that it is subtending an angle at the circumference, which is y. So y is equals to 70 degrees. And the reason for that is angle at center twice the angle at the circumference. So okay, we have 70 degrees here. But then remember, here we should also have 90 degrees because this is a radius and it is perpendicular to the tangent. But if you can check here, we are given a pair of parallel lines. Whenever we have parallel lines here, we think along the lines of maths is fun. So we want to see if we have any corresponding angles, any co-interior angles, or any alternate angles. But if you can just follow through here, you can see that there is a Z forming. So this is D, C, and then bends like that. Then you can see this is a Z. So meaning these are alternate angles. What do we know about alternate angles? Alternate angles are equal. So this angle here should be equals to 70 degrees. We'll call that angle CBA. So angle CBA is equals to 70 degrees. And the reason is alternate angles. Then let's offer the pair of parallel lines. We'll say for CD parallel to AT. So for CD parallel to AT. So we have 70 degrees here. But then we know that angle OBA should be equals to 90 degrees. And this is because tan is perpendicular to radius. Now OBA can be defined as m plus 70. So we have m plus 70 degrees is equals to 90 degrees. Then m should be 90 degrees minus 70 degrees, meaning m is equals to 20 degrees.